Hello everyone, welcome to the course Formal Languages and Automata Theory. This is lecture number 11. In this lecture, we are going to discuss about construction of NFA or designing of NFAs. Let me share the screen to discuss about today's concept. Today, we are going to discuss about language accepted by NFA and design or construct NFAs for the given language. And when you're going to see the definition of language accepted by NFA, already we have seen the same definition for DFA also. A finite automata is said to accept a language if all the strings in the language should be accepted and all the strings not in the language are rejected. Already we have seen this definition. Now based on this, we are going to construct an NFA which accepts set of all strings over A comma B, where each string starts with an A. The first thing what we need to do is we need to write the language. What is the language we are going to write? L equal to A, AB, A. In this, if you are going to observe here, all the strings have started with A. Now, is this a finite or infinite? This is an infinite one. This is an infinite one. Can we able to draw a DFA or not? Now we need to decide. We will try whether we can able to draw a DFA or not. Now by taking the minimum string of A, we are going to represent the structure Q naught on A. It is going to reach the final state Q1. This is the minimum structure we have represented. Now based on this, we need to construct an NFA. For NFA, there is no any restrictions. We need to have on all states, all input symbols to be represented. Without symbol also, we can represent an NFA. Now based on that, for Q naught, without representing B also, I can have an NFA can be constructed. I'm not representing any symbol for B on Q naught. Now by seeing A at the starting, I'm going to reach the final state. This is my first statement. Now for Q1, what we need to do? We are going to represent something. What are the input symbols that can be represented for Q1? Just observe A. After this A, starting symbol of A, after this, whatever the symbols I am going to get, that may be number of A's or number of B's. Whatever I am going to get, I am going to just accept it. That means that can be represented as self loop A comma B. Right? This is an NFA. In an NFA, I told you for all the states, we no need to represent all the symbols. That's why for Q naught, if I am not representing the B symbol also, this becomes an NFA. Now, how we are going to check the string acceptance. First, consider the example ABB, whether the string is present in the language and it is going to be accepted by the finite automata or not. First, represent Q naught on A. Q naught on A, where I'm going to Q1. Q naught on A, I'm going to Q1. Q1 on, the next input symbol is B. I'm in Q1 only. And Q1 on B, I am moving to Q1 itself. And here Q1 is the final state. That's why the string is going to be accepted. Then coming to string rejectance. Q naught on B. I don't have any transition. That's why it is going to stop here itself. And it is not reaching any final state. That's why the string is going to be rejected. Now, You can see the actual diagram how we are going to represent NFA that accepts set of all strings over A comma B, where each string starts with A. In this way, you can have the representation of NFA for ending with a string A or containing A or starting with AB. Like this way, we have seen the problems with DFA. The same thing can be represented in NFA also. And coming to the learning outcomes, by the end of this lecture, the student can able to design the NFA for the given language. Thank you.